In section 3.3, we're going to look at some different rules for differentiation. In section 3.1, we learned the definition of a derivative, and we used the limit as h approaches 0 of f of x plus h minus f of x all over h to calculate a derivative. Or if we were finding the derivative at a point, we used the formula of the limit as x approaches a of f of x minus f of a over x minus a. But to find derivatives using these limit procedures was very tedious and time-consuming, so mathematicians did develop some, if you want to say, shortcut rules to finding derivatives. And the first rule that we're going to talk about is called the constant rule. And basically it says that if a function is a constant, the derivative of the constant is equal to 0. And in Lebanese notation, they write it like this. So the derivative of a constant with respect to x is equal to 0. So if we're asked to differentiate f of x equals 7, well, that answer is going to be 0. Okay, and if you stop and think about it from a graphical point of view, the function f of x equals 7 is really a horizontal line at y equals 7. And if you drew a tangent line at any point on that line, the slope of the tangent line would be 0. And if you recall, a derivative represents the slope of the tangent line. So the slope of the tangent line is always going to be 0 for a horizontal line. The derivative of pi, same thing, is going to be 0 because pi is a constant. All right, the last example, again, I think you're catching the hang of it. The derivative of negative 4.5, whether it's positive, negative, really doesn't matter. It's a constant, so the derivative is 0. Okay, the power rule. The power rule is used when n is a positive integer. Okay, so our exponent right now, we're going to limit it to a positive integer. And the rule says I bring the exponent out front and I subtract 1 from the exponent. So if we're looking at f of x is equal to x to the 7th, to take the derivative, the 7 would come out front. I would subtract 1 from 7 to get 6. So my final answer would be 7x to the 6th. If I have y equals x to the 100th, again, the 100 would come out front. I'd subtract 1 from the exponent, and I would get y prime is equal to 100x to the 99th. If I had the derivative of u, and the function is u to the 9th, again, if I take the derivative would be 9u to the 8th. So the 9 comes out front, and I subtract 1 from the exponent. All right, in this next example, we're asked to find the equation of a tangent line to the curve y equals x to the 6th at the point -2 and 64. And if you recall, to find the equation of a tangent line, you need both slope and point. So the first thing I'm going to do is I'm going to calculate the slope, and the slope is really the derivative. And the derivative is going to be 6x to the 5th. And now I am going to evaluate the derivative at the x-coordinate of -2. So this is going to be 6 times -2 to the 5th power. So it's going to be 6 times -32. And that is going to be -192. So that's my slope of my tangent line when x is -2. So now to find the equation, I'm going to use the point slope formula. Y minus y1 is equal to mx minus x1. So y subtract 64 is equal to -2. Sorry, not -2, but it is, let me just erase that. It would be -192, x subtract -2, which would be x plus 2. And depending on what form they want us to write our final answer in, we would manipulate the final answer to whatever form they want us to calculate. So if we put it in point or slope-intercept form, I would distribute the -192. So I would get -192x, and -192 times 2 is going to be 384. And then if I add 64 to the other side, I would get -192x minus 320. Okay, now we're going to extend our power rule to let our exponent be any real number. So before we said the exponent had to be a natural number, but now we're going to let it be any real number. And the power rule is the same thing. I bring the exponent up front and I subtract 1 from the exponent. So in question A, before I can take the derivative, I'm going to move that x cubed up to the top to become x to the minus 3. The derivative is going to be negative 3 x to the minus 4. And if we write this without a negative exponent, the x to the 4th could go down to the bottom, and that would be your final answer. For B, the first thing I do is get rid of my radical by writing it as a rational exponent. So now the derivative is 1/2 x raised to the minus 1/2, which is really 1 over 2x to the 1/2. Now some books might even write it like this. I know some people might say, oh, we're not allowed to have a radical in the denominator, but again, this is just an expression. This is not an answer. It's not a numerical answer, so we are allowed to leave a radical in the denominator. The constant multiple rule says that if we have a constant in front of our function, we can take the derivative of the function and just times it by the constant. So if we take a look at 8x cubed, the derivative, 3 comes out front, 3 times 8 is 24, I subtract 1 from the exponent. If I have y equals 6x to the 8/3, again, I bring the 8/3 out front, and 8 times 6 would be 48 over 3, and I subtract 1 from 8/3, so I subtract 3/3, and I'll get 5/3. And again, if I was to divide, 48 by 3 is 16x to the 5/3, and that would be my final answer. Again, there should be an x here, not a u. It's a misprint. Okay, so the last example we're going to look at today says we're looking for points on the hyperbola y, or x times y equals 12, where the tangent line is parallel to the line 3x plus y equals 0. So first of all, my function, if I was to rewrite it in terms of y equals, would be 12 over x, which would really be 12x to the minus 1. Now, we want to find points here where the tangent line is parallel to the line 3x plus y equals 0. So if I was to isolate this line and isolate y, I'd get y equals negative 3x. So the slope of this line is negative 3. And if my tangent line is parallel to this line, my tangent line must also have a slope of negative 3. So I go back to my function and I take the derivative, which is really a negative 12 over x squared if I was to move the exponent with a negative exponent to the denominator. Now, my tangent line is represented by, or the slope of my tangent line is represented by this, and it's parallel to the line y equals negative 3x. This slope must be negative 3. So I'm going to let negative 3 equal negative 12 over x squared. Multiplying both sides by x squared, I get negative 3x squared equals negative 12. Divide by negative 3, I get 4. And square root, and I'm going to get plus or minus 2. And again, we're looking for points, which means more than 1. So I should have more than one x answer, and I do. So now I need to find the y coordinate for each of these points. And our original function was y equals 12 over x. So if x is equal to 2, y is going to be 6. So my one point where the slope of the tangent line is negative 3 is going to be 2 over 6. And if y equals negative, or x equals negative 2, y is going to be negative 6. So those would be the two coordinates where the slope of the tangent line is negative 3. So anytime they're asking you to find the points where a tangent line is drawn, you must be looking for the slope somewhere. And in this particular question, the slope wasn't given to you directly. You have to isolate this function in the form y equals mx plus b to find the slope. Okay, in the next question, this was a multiple choice question from an actual AP exam. And it says the tangent line to the graph of the function at the point 1, 7 passes through the point negative 2, negative 2. Find f prime of 1. So f prime of 1 is the derivative at 1, which means the slope of the tangent line at 1. Well, if we kind of draw a situation here, let's say that this is my point 1, 7, and we drew a tangent line to that point. Okay, I guess we should be touching the curve. Okay, now it says there's another point on the tangent line that is negative 2 and negative 2. So if I know my 2 points, then I should rewrite this. You can see that a little neater. That was 1 and 7. If you know the 2 points on the same red line, you can find the slope by using just your regular slope formula. So 7 minus -2 all over 1 minus -2. This works out to be 9 over 3, which is 3. So the slope of the tangent line is going to be equal to 3. So this question was just really testing whether you understood what f prime of 1 meant. And f prime of 1 meant the slope of the tangent line. And we were able to find the slope of the tangent line without even knowing the function because we had 2 points on the tangent line to calculate the slope. Okay, you'll get a handout in class today that deals with the power rule. So there is the assignment. So copy that down and I'll give you the handout in class and you can try those on your own.